This set of notes is going to cover Circle Theorem 3 and Circle Theorem 4 on pages 45 and 46 of your notes. So fill out your table of contents and then turn to page 45. We'll start with Circle Theorem number 3. So I just cut out examples from our exploration in class, so you can do that as well to tape in an example into your notes. In Circle Theorem 3, we found that any two inscribed angles that intersect the same arc are congruent. So let's do some highlighting to show what that means. We have this angle that I'm going to highlight in pink, and it has two endpoints intersecting the circle along this arc. It is this blue arc. And we have this other angle that I'm going to highlight in green, and its endpoints are also the endpoints of that same arc. So according to Circle Theorem 3, that would tell us that both of those angles, the pink angle and the green angle, are congruent. So let's practice using this theorem. So again, I just cut out one of the circles from our examples in class, and then I filled in angle A and angle B, and we are looking for angle B. So I tend to highlight the angle that I'm looking for first, just to check to see if I can find any other angles that are intersecting the same arc. So that blue arc is the arc that angle B is intersecting. And I am noticing that I have those two lines coming from that same arc, and I found that angle A is intersecting that same arc. So that tells us that angle A is congruent to angle B. So the measure of angle B has to equal the same 28 degrees. So let's think about another example. In this example, again, I cut out one of the circles from our Explore, and I drew in this diagram. So we know that angle C is 68 degrees, and we are looking for angle D. So I'm going to go ahead and highlight that angle D. We're at D, it's not the whole angle D. And that shows me that this arc BC is the arc that this pink angle intersects. So as I'm looking at that, I see that this angle up here by A that I just highlighted in green is the same angle. So if I could figure out that angle, I would know what angle D was. We have one more piece of important information in this diagram. Notice that AC, and I'm going to put little dots along AC. AC is a diameter. So thinking back to Circle Theorem number 1, if I have a diameter, that tells me the angle across from the diameter is a 90-degree angle. So we know that angle B is 90 degrees. Since we have a triangle ABC, we can figure out this angle up here by using our angle sum theorem for triangles. So we're going to take 180, subtract the 90-degree angle and the 68-degree angle, and that will tell us what that other angle is. So that tells us that this green angle is 22 degrees, and we know that that angle has to be the same as the angle we were looking for. So the angle we are looking for is 22 degrees. Okay. All right, on to Circle Theorem number 4. On page 46, again, I just chose to cut out one of the circles that we had from our Explore Day, and I labeled the vertices A, B, C, and D. All right, circle theorem 4, we discovered that the opposite angles in a cyclic quadrilateral, remember that means that all 4 vertices lie on the circle, sum to 180 degrees. So for example, in this diagram, angle A and angle C are opposite, and so A plus C will equal 180 degrees, and angle D and B are opposite, so B plus D will equal 180 degrees. So our first example, we are given this angle is 115 degrees, and this angle is 88 degrees. So I can use this 88 degree angle to find x by subtracting from 180. So x equals 92 degrees. We can do the same thing for y. We can take 180 and subtract the 115. And find that y equals 65 degrees. Okay. All right, in our second example, this time we are given this exterior angle is 150 degrees. This angle is 92 degrees. And then we have S and W, so those are the two that we are looking for. I'm going to start with W. So I know that it is across from the 92 degree angle, so we can just subtract from 180. So W equals 88 degrees. But for angle S, we don't know the opposite angle yet. We have to use some other information. And the piece of information we need to use is that the 150 and the angle opposite S make a linear pair. Those two together will add up to 180 degrees. So 180 minus 150 will give us 30 degrees for this angle. But again, we would have to subtract 180 minus 30 to get S. We already know what that's going to equal because we just did that subtraction. 180 minus 30 has to equal that 150 that we started with. So angle S has to equal 150 degrees.